Hi, my name is Chris LeBou. I'm an application engineer in the embedded computing group here at Advantech. Today I'd like to go over the Life Prediction utility available for our Advantech SQF SSDs. Why do we suggest Life Prediction? Well, the first reason is to provide our customers with an accurate way to gauge the expected life of their SSDs. One of the most common metrics used in the industry to calculate the potential life of an SSD is TBW. This measurement can indicate the amount of data that can be written to a drive, which can then be used to estimate its lifespan. The problem is that many customers are unaware of the actual amount of data that may be written in an application on a daily basis. This makes this metric hard to apply. It becomes more of a guess than a practical number when trying to find the correct SSD based on a required lifespan. For instance, one application such as surveillance may write many terabytes in a day even, and this could be multiple times the maximum capacity of a drive, versus something like the digital signage market, which may not write more than a few gigs a day. It may not fill up an entire SSD in an entire year's span. By using the Life Predict utility, customers can see exactly how much data is being written to a drive on a daily basis, which will help choose the best technology to fit their lifespan requirements. The second reason is to find the remaining life of an SSD. Say, for instance, if a customer has been using a drive and they want to predict, well, what is the remaining life of this drive that's been running for many years in this application that I've already been using. It's based on the same concept of gathering data over a period of time and applying that to the remaining life of the smart information on the drive. This information can serve to schedule preventative maintenance and provide customers an idea of when they can service these units or replace them in the near future or long-term future. There are three major factors which affect the service life of an SSD. The first is volume, or the amount of data being written to a drive on a daily basis. The second is technology. While it is the inherent nature of NAND flash to degrade from usage over time, the type of NAND flash technology used can greatly affect the potential life of the SSD. And the third is write amplification. This is the maintenance or housekeeping required to maintain data integrity. The SSD's controller, for instance, will shift data around in cells from time to time to maintain the wear leveling on the SSD. This is to prevent the same cells from wearing out over time from overusage on one block, basically. We offer a wide variety of NAND flash such as SLC, MLC, Ultra MLC, and even 3D NAND that can provide a range of potential life cycles to fit our customers' needs. Our designs use advanced algorithms to reduce write overhead, like fragment writing, which does not require cleaning of a block before writing new data on it. This helps reduce unnecessary wear on the drive. Now let's take a look at two of the life prediction formulas. The first is for expected life. This is the SSD life estimation, which will be a life prediction given the current test environment. For reference, the flash maximum PE cycles is the total amount of program erase cycles or that can be written to the drive. This is very similar to TBW. And we have the average erase cycles, which is the amount of times the drive has been written to its full capacity during this test, and of course the test time. And for remaining life, this is the SSD estimated lifetime. This will give an estimation of when the SSD could go bad given the current and previous usage. For reference, the power on hours is an amount of time that includes all previous time that the drive has been used, and it also includes the current time that the test period has been going on. This is a part of the smart information stored on the drive. And the safety factor is a buffer period that we build into this utility to allow for preventative maintenance replacements of these drives. By default, this factor is a factor of 0.8. Now let's do a quick demonstration of how to use the utility. You'll see in the bottom left is our information for our text fixture for reference. I will also be discussing this during the video during the setup. So let's go ahead and start the demonstration now. Alright, so now let's take a look at the SSD Life Prediction function in the SQF utility. On the left here, I have opened the SQF utility and picked our drive that we're going to be testing in this case. It's an SQF SM4 64 gig S9C. That's an MLC SQF mSATA SSD. On the right here, I have a burn-in test open. We're going to be reading and writing to the drive 8 hours a day for the next 4 days to simulate a basic heavy workload during an 8-hour work day. During this time period, we're going to be running the life prediction over here on the drive, which will take data points throughout that time period, and we're going to then calculate at the end of 4 days what could the expected life given this workload be. So I'm going to go ahead and start the Life Predict utility here, and we're going to let this run for 4 days, and at the end of 4 days we'll come back and we'll get the results and see how long this drive has to last in this particular environment. So I'm going to begin the test now, and we'll come back in a few days and check on it. Alright, let's begin. Alright, and we're back. It's been about 71 hours, and this test was started on Tuesday. We're finishing up on Friday. And what we can see here is that we've written about a little over 3 terabytes to this 64 gig drive. So this is an exceptionally high amount of data for this particular scenario. And this is over 51 times the size of the drive. So we were writing over 10 times a day the full capacity of this drive. This was a very heavy workload, and what we can see here is we started with the drive at an estimated time of a life being about the end of 2020, about 2 years. And now for this particular workload where we were writing 800 gigs a day, the estimated life, if we were to keep at this pace, is about 109 days. So around about 3 months from now, we could expect to see this drive starting to have some issues. This is a great example of a situation where maybe MLC is not the technology that should be recommended, and Ultra MLC would be a much more robust technology to perform for a significantly longer period of time given the amount of data that is being written to this drive. And that's why we have this application. so that our customers can test in their environments to see if the technology is actually a good fit for their application.